Alright, welcome to a tutorial on asynchronous programming for Flutter. In this tutorial, we're not actually going to use Flutter or make an app. We're just going to use Dartpad because this is going to be a tutorial on just the language features and the keywords that we're going to need to use to make our app work asynchronously. So asynchronous, conceptually, what that means is it's something that takes some amount of time to complete and you don't know when it's going to happen. And the code, it can make different things happen in parallel. So imagine you had something like an API request, like something on the internet. That's going to take some actual amount of time, like maybe 50 milliseconds or something like that. And imagine you had 10 of those, you could fire them all in parallel, right? 10 of them in a row. And then at some point in the future, they're all either going to complete, complete with a value or complete with an error. And we're going to look at how we're going to write that stuff and deal with these new keywords. Oh, well, not new necessarily, but maybe new to you. So that we can, in the future, in Firebase, listen to our documents and get real-time updates through a stream. So that's really what the goal of this is a preparation to do some pretty heavy-duty async stuff with Firestore so we can get real-time updates from our documents. So these are what we're going to cover. We're going to do a little reminder on generic types, go over future, and the async await keywords, and then a stream and a stream subscription. So generic types. This is just a type that you can pass a class, and it says, okay, well, the type that I'm dealing with is T, and T is a common syntax for just any type, T for type. So you probably use these a bunch with lists, right? You have a list of something. If you have a list of ints, it's still a list class, but it's a list of int, and in the pointy brackets, you could put int there. You can't put a string in a list of ints, and futures are similar. So a future is the class that houses something asynchronous, and what it's going to do is eventually complete with a value of T. So imagine you had a future of document snapshot, and you're getting a document from Firestore. Well, that would be a future of document snapshot. T would be document snapshot. And then the document snapshot can also have its own generic type of the type of data that it's going to have in it. So it's just a little reminder on generic types because we're going to use them because it's quite nice to put the generic types in for all of your futures so that you know what type they're going to complete with when you're consuming that code in another place. So what we got here is a void main, and it's printing when main is started. And then it calls this method print after delay 5 times, and then it prints main has ended. So that method is right here, print after a delay. So let's look at what it's doing here. So it returns a future void. What that means is when it completes, it's going to complete with the type of void, which kind of means it doesn't really complete with anything. It's just done or it isn't done. It takes in an int for seconds, and this method is asynchronous, so it has to be marked with the async keyword. That means that it's going to do asynchronous operations, and it's going to complete at some time in the future. And the amount of time in the future it's going to complete, we're controlling with this. So here we have the await keyword, which means it's this code, even though it's asynchronous, it's going to run line by line as though it was synchronous, right? So this line, because we've called await, is going to run and complete in its entirety before we hit this print statement. If we didn't have this, it actually wouldn't. It would run this line, and then it would run this line, and then at some point in the future, this would complete and we wouldn't really do anything with the value. So the future class has some static methods that can be useful. One of them is delayed. And what delayed is it takes in a duration, so you can just wait for some period of time. You can also optionally pass in a function to run as well, but we're not going to. We're just going to print delayed some amount of seconds. Oops, I deleted an extra bracket there. Okay, so let's think about how this is going to run. So we don't have this as async. And we're calling a bunch of asynchronous functions in a row. So what's going to happen is kind of interesting, right? So it's going to hit this. We're going to go main is started. And then basically we're going to do what's called fire and forget with async. And it's going to go print, 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 print. And then it's going to go main has ended. And because we're not using the await keyword, it's going to run all of these lines really, really quick, one after another, before anything even prints. So what we're going to see on the output is main has started. Then it's going to fire off all these. And then it's going to go main has ended, and then it will go print 1, 2, 3, 4, 5. So let's see that in action here. So we go run. And it prints main has started, main has ended, and then on different isolates, in different asynchronous processes, it then counts 1, 2, 3, 4, 5. So let's change this up. Let's say we didn't want to print main has ended until everything had completed. What we need to do is mark this as async, and you can make your main async, that's fine. And now what we got to do is call await on all these things. Okay, so now what's going to happen is we're going to see main has started, and then because we've called await on this future, it's going to wait 1 whole second and then print delayed 1 second, and then it's going to call this one an await, and this one's going to be 2 seconds. So previously, because all of these fired off at the same time, it just counted 1, 2, 3, 4, 5, and it took 5 seconds because the delay for 5 seconds started at the same time as the 1 second. But now, because we are waiting for each one to finish, this is going to take much longer because it's going to be 1 plus 2 plus 3 plus 4 plus 5 seconds long to run. So let's see that go. Okay, so we see main has started, delayed 1 second. 1, 2, 1, 2, 3, 1, 2, 3, 4, and then the 5th one. And then it will print main has ended after. So this makes this code, even though it's doing asynchronous stuff, read a lot like synchronous code, which only moves on to the next line when the previous one has finished. So let's now look at something like returning a value from a future. So let's say you had something on the internet and you want to get the actual response out of it or the value out of the future. Let's change this to being an int. And now because it must return a future int, we're actually going to get a compile error because we're not returning an int. So let's just go here and go return seconds. And now it is actually returning a future int because we're returning this value. So in any function that's marked as async, it's going to return a future. This is a requirement of async, although the exception is just void if it does nothing. But let's look. So this actually can't return an int because async means it must have a return type of future. The other option is void. If you don't even want it to be awaitable, it'll just fire and forget, and that's all you can do. But that would mean we couldn't return an int here. So let's change it back to the future int. So now let's just look at one of them. So let's go var test is equal to print after delay. And what type is test when we just put var? The answer is it's a future int, right? It's not the actual seconds yet because we haven't awaited it. So if we go here and go print test.runtime type, we haven't awaited it. So we go main is started. It's a future int because this line will print before the one that's delayed, and it's delayed by 1 second. So let's say obviously we wanted to get the value out of this asynchronous method that we really want is the int. All we got to do is go await. So when we await it, now test is actually an int, and you might as well print test itself as well. Main is started, delayed 1 second, int 1, right? Because it's a future int, and when we await it, we get the generic type out of it, the value. There's another way that a future can complete, and that's with an error. So instead of returning seconds, let's throw it, right? So you can throw anything. Normally you would throw an exception, but you can throw it whatever you want in Dart. So this is going to throw an int, right? So that's going to mean that this future actually completes with an error. So let's see what happens when we do that. So we see main is started, delayed 1 second, uncaught error 1, right? So if you have this completing with an error, in your code where you're awaiting it, this is going to be an uncaught exception unless you wrap it with a try catch. So in this, we don't have test anymore because it's out of scope. But anyways, we are going to print after a delay, and then we're going to print our exception, which isn't really an exception. We delayed 1 second, and then we threw it, and then that was caught by E here. So we can also put the type on catching an exception. So this would be on int, we would catch E, and then it would catch E, and we know that it's an int in here. If we did something else like on exception catch E, well then it wouldn't be caught because we don't actually have a catch for that particular thing that it's throwing. Okay, so that's async await. Let's now look at streams and stream subscriptions. So streams and stream subscriptions are really useful for listening to the state of your app. For example, let's say that something had an error and you want to show a dialog if that error happens. But that error, it might be asynchronous in the future, right? I'm trying to load a page or load something from Firestore or something like that, and there's an error. Well, that's going to be asynchronous, and it's going to complete with an error at some point. And then on that error, what we want to do is show a dialog. What we're going to do with that is look at a stream and stream subscription. So streams also have a generic type. Let's just delete this one. We're not going to use it anymore. And now we're going to look at this async generator. So a stream is a bit like a list. It's a source of asynchronous data events. So like a list, there's things in a row that are coming out of the stream. But unlike a list, you don't know when they're going to come out, you don't know how many, and you don't even know if there's going to be any at all. It's actually valid to have a stream that never outputs an event whatsoever, right? Imagine you had an error handler, like an error listener, and you want to show a dialog on an error. Well, if there's no error, it's never going to actually have something output on the stream. So to make your own stream, which is a bit uncommon, you can use the async star. And the star marks this method as an async generator. And this sounds a bit scary, but it's not too complicated. Basically, it's like you're building the stream and just outputting every single event on it manually, right? So the way that you output on the stream, instead of returning k, we're going to go yield. And yield is a keyword which outputs something onto a stream. So you can see we start at 0 and we count up to some amount. We wait 1 second and we yield that number. So let's assign this to a variable here. Oops. And when we run it, nothing's really going to happen. Let's I don't know, print test here. So main is started, and we get a controller stream, which is just a stream really of ints. But we're not doing anything with the actual values, the ints that are yielded out. So how do we get those? Well, we get them via a method called listen. So let's do that. So let's go test.listen. And listen gives us a way to have a callback whenever there is a event on the stream, which in our case is going to be a new int. And it needs a function. So in here, we can do something with the value that's output on the stream. In our case, this is going to be an int, right? Because it's a stream of ints. And the int that it's going to be is whatever we yielded here with k. So let's do that. Let's just print it. And because we're waiting for 1 second and then yielding, we're just going to get a count up to from 0 to 4 every second. Like so. So this is how we're going to listen to our document snapshots. So in Firestore, they have it set up so that there are real-time updates, and you can just listen for the changes on a document and do something the instant that it changes. And it's going to pipe all that new data to your app without you having to refetch it manually. And this is how we're going to be able to get real-time updates. So we're going to do that in the next tutorial. But one thing that we have to be careful of is that this listen never stops. And in Flutter, with the linter, it does warn you if you have stream subscriptions that aren't closed. So let's actually assign listen to a variable as well. It is a controller subscription of ints, right? So a subscription means we're subscribed to the stream, and we're going to keep doing this callback whenever there is a new event on the stream forever. All right. And what we need to do is actually cancel this subscription when we don't want to listen to it anymore. This is quite important in Flutter apps, because if you're doing something like calling a set state or something like that in your callback, and if that widget is disposed, like they went back a screen, if that listener is still listening, you're going to get errors where it's you're going to be calling set state when that widget doesn't exist anymore, and that you can't do that. So what we can do to cancel it is just cancel it. Now let's think about what's going to happen the way that I got this set up exactly, right? Even though main is async, it doesn't need to be, right? Because this is just synchronous code. We're just getting things that are asynchronous, but it's a bit confusing because we're doing it synchronously, meaning this line will run, and then this line, and then this line, and it's not going to wait for anything to happen, right? So if it's not waiting for anything to happen, what's going to happen is we're going to get our stream here, then we're going to get a subscription, and we're going to give this callback, and then we're going to instantly cancel it before it even prints anything, because it's going to take a full second to get a value out on this stream. So this print I is not going to print anything. We run main, and we don't get anything on the console, right? Because we're not actually waiting to cancel it. So if we then waited for 5 seconds, then we'd see the output again. So let's do that. Oh, you cannot use a wait in a function that is not asynchronous. So we need to mark it as async again, because now this itself is asynchronous, this method, our main. So it goes 0, 1, 2, 3. And it didn't print the last one, I think, because it's exactly 5 seconds. So if we went 6 and made sure that it was actually waiting long enough for everything to get outputted, then it would probably print the last one as well. There we go. So now we see the last output. Okay, I think there's one last thing that I want to go over here that wasn't in the topics to cover, and that is if you have a list of futures and you want to wait for all of them to be done. So let's go back to where we had the delay method. Here we go, print after delay. Let's get rid of this one. Okay, let's say hypothetically what I wanted to do was fire off all 5 of these, and we want to just wait until the last one is done, until they're all completed, but we want them to run in parallel, and then we move on to something else. What we're going to do is use a method that's in the future class, and it allows us to wait an entire list of futures. So it's just called wait, and you can see that it takes in an iterable of futures, and it's going to allow us to wait all of them at once. So let's do that. Okay, so it is taking in its list of futures, right? But wait, if you want to, oh, it doesn't highlight it. Oh, there we go. Actually returns a future of its own, which means if we want to wait for something to be, wait for all of these to be done, we also need to await the result of this. So now what we're going to see is that they're all started at the same time. Oh, I forgot that this is still throwing. Sorry. let's not throw for this example. Right, they're all going and they're all done. Right, so we waited for all 5 of these to go, but they ran in parallel and they all started at the same time, which is really useful if you have like 3 or 4 API requests that you're going to make, and it doesn't matter what order they're in, you just need all of them to complete at some point. So you can also get the value from future.wait if they all have the same return type. So let's do that. Let's change this back to an int. And let's print test here. So again, it's going to wait for all of them, but now we're going to get the output, right? And it gave us a list of 1, 2, 3, 4, 5. And that's because each one of these futures resolved with an int, and we waited for all of them, and they all had the same return type, right? And then we printed it down here, and this is just a list of ints. So if these had different types, this wouldn't work quite as well. I think it would be a list of dynamic, but yeah, for things that return the same type, have the same generic type here, future.wait is great. Or maybe they don't have the same generic type and you just happen to want to wait for all of them. Okay, yeah, so I think that'll do it for now. This is going to set us up to get real-time updates from our Firestore for the next tutorial. So yeah, hope you enjoy.